Okay, this is the video tutorial for chapter 2 of my textbook. And this particular chapter deals with a block with a central hole, or what is called a notch plate, and it is loaded under tension from both sides. So here's the problem that we're looking at, and the dimensions and everything are given down below. We are assuming that this is a linear elastic material, Young's modulus and Poisson ratio, uh, and the load P is very small, so it keeps it in the elastic range, 0.1 megapascal. Now, uh, I will be doing this problem two different ways. One is uh, the standard process of creating the geometry exactly as it is, and then meshing it and loading it. And then after I do that, I will come back and repeat the same problem, except that the geometry that you saw blocked with the central hole, I'll put at some fillets there. So the idea is that if the fillets are not important, you can remove it. You should be able to remove it from the geometry without actually affecting potentially the original geometry that was given to you. Okay? This is where the concept of abstraction shape comes into the picture. So I'll do the problem two different ways. One is straightforward way, then I come back and remodel my geometry so that it has fillets, and I want to be able to remove those fillets without affecting the original geometry. Okay, and this uh, idea is based on the concept of shaped abstraction, which was introduced to me by Mr. David Martin, who's working at the SAW Corporation, and he introduced me this. So thanks, David. Okay, so these are a few slides about shape abstraction, but we'll get to that as we need it. Okay. All right. So let me see. There is the 3D experience interface. So start with the part file. The first time I'm going to do this problem, don't worry about the abstraction shape. Okay. So on a convenient plane, on that vertical plane, I'll sketch a geometry just like I showed you. We have a hole here, or a circle. This is going to be the hole. Dimension 25 millimeters. 25 millimeters. And then we have a rectangle. And the dimensions of the rectangles are 150 by 100. So this is going to be 150 by 100 on the side. And oops, it's 100, right? Okay, and then exit and pad it in both directions, or in one direction, whatever you want. I'm not going to be using symmetry. This problem does have 3 planes of symmetry, and I'm going to be using none of them. So the width of this plate is 20 millimeters. If you wonder, 20 millimeter width, so if I do it symmetrically, put down 10. How about that? 10 millimeters symmetrically, and let me see for a second. I think this should be 20. Okay, so this is a geometry. Please keep in mind that this problem does have planes of symmetry, and I'm not using it. Okay, let's apply some material to this thing. So material, create a material. So say chapter 2. It will create a shell here for me that I can go and populate it. This is well, let's see now. Here's the one. Right click. First of all, let's plug in the values here. Simulate, structural, mechanical, elasticity, and for Young's modulus, I put down 200 gigapascal, 200 GPa. Okay. What happened? I think it closed it on me. Let's try it again. 200 GPa and 0.3. That's all, right? And now I'm going to apply it. Right click, apply. I'm going to close this. I'm going to apply it to that part. And okay. Okay. So that's pretty much it. So we're going to go to uh, structure model creation. And the usual thing, the usual radio button, main body, etc. That's what we have been doing in the past. And that's, yeah. Okay, so that's pretty much it. So now we're going to create our scenario. Structural. Exclamation marks here. So if we do setup, apply our model, find our model, select it. Okay. This one turns green. And then procedure, static. Yeah, that's fine. And restraints. Well, let's do the load first. Load pressure on this face. Since I want it to be tensile, I put down negative 0.1 MPa. MPa. Okay, and same thing on that side. That side too. It looks like you have to do this thing one at a time. Okay, so that's fine. So another one on this side, exactly same numbers. Oops. Minus 0.1 MPa. MPa. Okay. Now, notice that if I run this thing, it will crash. The reason is that this can move as a rigid body under these two forces at the two ends, pressures on the two ends, and still be static equilibrium. Now, if I had taken three planes of symmetry, that rigid body motion would have been eliminated. But what I want to do, and I talked about it in the book and or in here, I'll apply the 1, 2, 3 rule. So this corner point does not move in direction 1, 2, 3. This one direction 1 and 2, and this one direction 1. Okay, it's called the 1, 2, 3 rule. This will take away the rigid body motion. So you go to restraints, restrain. This is fixed displacements. This bottom point does not move in directions x, y, z. The stop point does not move in directions x and y. Okay, see that? Directions 1 and 2. And the last one in direction, that's direction in this case, let me see for a second, this way. So that way will be y, right? Say okay. And the last condition is over here, does not move in direction y. This prevents the rigid body motion. If I run the problem, it will work. So not a big deal. This is not a hard problem. I'm not going to even bother doing the model and scenario checks. I'm just going to run it. I advise you guys to do it because I've done this problem many times. I've checked it for the book and there's nothing wrong with it. It works. So, okay, very simple problem. Needless to say that because of the hole, you have stress concentration on the top and the bottom, so this is not a very good mesh, but we're not interested in accuracy here. We just want to know the process. So there we are. So this is what we expect. Top and the bottom, high stresses, stress gradient, and therefore we can we have to define the mesh on the top and the bottom. Now, this is fine. However, I'm going to stop this. I'm going to stop this, and I'm going to repeat the same problem, except that I put some fillets here that at the end of the day, I don't want to mesh it because uh, it doesn't affect my problem. Those are non-critical regions. Okay, so let me close this. Start fresh. Okay, and close this. Although I could have used that same body, but anyway, let's try a brand new one. So this, think about it as part two, and this is where the abstraction shape come into the picture. So on this plane, I will draw the circle, 25 millimeters, 25 millimeters diameter. Yeah. Okay. Rectangle. This one is 150 millimeters, and the side one is 100. Okay, very good. Exit and pad it by 20 millimeters, right? 20 millimeters. I don't know what is the size here. 20 millimeters. Okay, did it. Good. All right. So on purpose, I'm going to put a fillet here. Actually, a fillet on all those four sides. Okay, so I'll put a fillet, which is under refine. I'll put a fillet over here, and I put a fillet of let's say 5 millimeters. So this is 1, 2, 3, and 4, and we say okay. So let's say hypothetically, this is the geometry that was given to me, and I just don't want to go and delete these fillets because maybe uh, this was given to me by another division in the company, and they don't want me to have access to these fillets to go and delete them. Okay, so let's apply material, by the way, too. Material browser. I think there was something called chapter 2. I already created it. So chapter 2. Oh, right there. Right click, apply, and close this. Apply it to that. Say okay, and we move on. Now, what we like to do is to create a kind of a dumb model of this, which is called the abstraction shape. So we go on the very top level, right here, right click, insert, abstraction shape. You can give it a name, so I'll call it my first round, my first okay, my first abstraction shape, because it could be that there's several of these that you want to do, but anyway, right here, you can see that it's created there. Okay, so what we're going to do is we're going to go to this 3D shape. Okay, we're going to copy it, and we go to the abstraction shape, double click on it so that you can activate it, and right click and uh, paste special. Oops. Okay, let's try it again. We go to the shape, 3D shape. Okay, take the part body, right click, copy, and double click on this my abstraction shape so that you go in there, activate it, and you say right click, or actually right click, special link, special paste, that's what I meant. As a result, with link. Okay, now apparently some applications in 3D Experience do not want this solid to be dumb solid to be in body 2. So I can move this thing up here to the part body, and this thing becomes empty, and people at the saw tell me that you better delete this. It's a good idea to delete it. We don't need it, okay? So what we have here is now this thing, okay? So what we can do is we can exit this. We can exit this. Exit meaning going to structural model. That's what I mean. And here in the past I've been doing main bodies. Now I should say select geometry. And for the geometry right there, I select the abstraction. See now, yeah. So you can expand this thing and take it from here or from the tree. Okay, so I'll say my abstraction shape, part body, but this is going to be basically a copy of what's up there. Okay, and we say okay, and we say okay. All right. Now, notice that I can mesh it, and it's going to mesh. It's going to mesh this these edges. Okay, it's going to mesh these fillets too. So there we are. You can see that, right? Okay. But these fillets are really not important to me. So what I would like to do is I would like to prevent them from being meshed. Okay. So I'm going to go here and I say I change to model prep. Model prep. See that? This guy has model, mesh, model prep. You click on it, okay? And there's something called defeaturing here. See that defeaturing? See the defeaturing here? You click on it, okay? And it says, okay, what is it that you want to defeature? You expand this thing and you say uh, fillets, right? Fillets, and start with the plus sign. It says, okay, why don't you delete the fill, defeature the fillets between this value and that value. Okay, so here I'm going to use maximum only, and I'm going to anything above 30 millimeter fillet radius, defeature it. 30 and preview. See, it identified all these four sides and says these are fillets that are less than 30 millimeter. You say okay, and now notice that it defeatured the original part is here. It was not touched. Okay, so if you say okay, this is it, so exit this, and if you update the mesh, notice that those fillets are gone. The rest of the problem is exactly like what it was before. So let's go ahead and actually finish this problem. Okay, so we go to scenario. Okay, so this is done. So we go to scenario, structure scenario, structural. Okay, so let's create a let's get rid of this exclamation red exclamation mark. Setup finite element model. That guy. We've done this thing so many times. So procedures, static, same thing as before. Load, pressure on this face. What did I put? Minus 0.1 MPa. What did I type here? Something is, let me check my, whatever I inputted. Load, pressure. Okay, let's try it again. Minus 0.1 big M, big P, A. That's better. And do it on the other side. Another pressure on this side. And minus 0.1 big M, big PA. Notice that the steps are identical to what I did before, except that I'm not using the original part, I'm using an abstracted shape. Okay, so that takes care of this. Let me get rid of these elements. So hide it. Okay, so we're going to apply restraints. This corner point was all three directions. This top corner point was in direction 1 and 2 for x and y. And this last one, that other corner point, was in direction y. This is called the 1, 2, 3 rule. Okay, yeah, that's pretty much it. So let's run it. Going against my own advice, I'm not going to check these things. This is a very simple problem. We are going to get the results in just a second. Get rid of this. There we are. Okay, so this abstraction shape is very useful. You don't mess around with the original part that was given to you. You create an approximation, or let me see now, a replicate of it, which can be used to basically defeature stuff. Good luck.